Hi all, this is a short video on tricks and tips for editing the lights features in your class clean dataset. How to identify clusters in particular, because you'll be using the mean center tool to create an individual light for each of the many lights in the gardens. Okay, so here we have our class clean dataset. You'll notice that it looks just like the one that you've got. Okay, and what we're going to do in here is open the attribute table for our light examples. Okay, and it's going to show everything at the moment. So we've got fountains and seats and bins and everything in there. So we're going to set our definition query first. So new definition query where name is equal to light. Okay, and you just need to tap down button there because you've got it's drawing from a list. So you want the light, we'll apply that, and we'll actually just add a clause in here where remove is equal to K. Apply. Okay. Right, so now we can see that the definition query has done what we want it to do, which is just display lights. And pretty quickly you can see that we have in some areas here very nice little clusters of lights. So it's going to be very quick and easy to check those ones. Okay, but what we're concerned about are these sort of outliers, spatial outliers in here, and potentially whether or not we've got a spatial outlier from one cluster sitting inside another cluster. That's going to make our locations quite inaccurate. So to get started, we're going to use our symbology for our class clean with our lights on. So under appearance, symbology, we're going to change it from a single symbol to unique values, and we're going to use our metadata string because that has our asset code. It's going to warn you that there's over 100 values. That's fine. There's 200 odd lights in the gardens. It's going to go through and give each of them a unique color. Now the pastels are nice but may not be sort of bright enough for good processing, so you can change your color scheme to make it a bit clearer to see. Okay, you can also change the size of your symbols in here too, so you can format all symbols, so you can change the size of the point features if you need to. Okay, so in here we can see we've got a distinct cluster of lights and a couple of outliers around it, and we've got at least 3 different colors. Now because we're using the metadata string as our symbology layer, we can assume that we've got at least 3 different values for the light at this location, okay, of the light feature. 3 different asset codes at this location. So let's go and have a look at that. We'll click our edit tab and we're going to use our select tool to highlight those records, and then we're going to look at this set here. Okay, if we double click on our metadata string, we can see immediately that we've got lots and lots of them that are all 2502, 2502, 2502, and then we've got one unknown. Now if we highlight to this side, it will highlight that one for us, so we can see that it's an unknown. Now this is clearly either a very inaccurate location or somebody hasn't seen the asset code for it, hasn't entered the asset code in, so we will probably want to remove that one. So in here we can simply type an R and hit enter, and you'll see it immediately disappears from our layer because our definition query says only display if remove equals K. Now our next one is a trickier question. This one here is 102584, okay, and this one is 102504. Okay, now those two may be the same light, but they're definitely not associated with this cluster of lights here, and there's no other light clusters nearby. So for these two, we are going to, here we go, 10284, we're going to just type in R for remove, and we'll highlight this one, and we'll type an R in for remove, enter. Okay, so now what we've got left is a single cluster of lights with every one of those samples having the same metadata string. Okay, and that should take care of a mean center for the location of that light. Alright, now we can have a quick look at other areas. So we've got, you know, several light features here that are distinctly separate from everybody else. So we can just select those. We're only displaying the selected ones. If you right click on the remove header cell, say calculate field, and just enter R, you can apply and it will apply to all of them. Okay, quickly sorted. You can do it. There we go. Okay, now for 3, it's probably just as easy to type R 3 times to edit, but as you get to bigger clusters, or if you start selecting a range of features that are all outside, so you're just using the shift key, you can select multiple sets, so hold down the shift key as you go. You can say, well, all of these here are clearly inaccurate, and I will just remove them from my layer. Okay, this one out here by itself. We've got some here that are in the duck ponds. Okay, so we can say all of those, and then you can once again just right click, calculate the field, and say remove and apply. And we'll go through, mark them all as R. This is taking a little longer than usual because I'm recording the screen as well. And okay, and now you can see that all of these features that were out here are now removed, and that gives you a quick way to edit lights. Here's another little cluster. We can see, actually, if we look at the colors, you can see this section here, we've got 2 different colors in here, so we'll sort by that. And yes, we've got the 2500s there and the 2501s underneath. Okay, and so if we have a quick look at the 2500s, so we can highlight the 2500 set and have a look. Okay, so this gives us our 2500 set. We can see that there's one that sort of sits a good way north and in amongst the other lights there. So if we just redo our search, we can just grab that light and just say, well, you're spatially inaccurate, hit the R and remove it. Okay, and we can check this bunch up here. Okay, they're all 2501s, but this one here is a long way away from its neighbours, so we're just going to remove it as well. Okay, it's important here not to remove too many. We need at least 3 points to create a standard deviational ellipse, so going through and just picking one out at the end is not going to help you. Okay, we need to go through and check that we're getting a representative sample, because it's important to get the locations of our lights right, and averaging our location records is a very good way of doing that. Thank you.